Welcome back, and welcome to our third video on this revision series on calculus. Now, in the last two videos we went through, first of all, what the derivative was and kind of going through a limit definition of derivative. In the last video we went through the four differentiation rules that helped us to actually find the derivative. And so if you remember from the last video, the first one, the four rules that we went through was a power rule. So if we are differentiating x to the power n, we bring down the power n times x, and we subtract 1 from the existing current power, so we get n minus 1. The second one was a chain rule. So if we're differentiating a function within a function, so if we're differentiating, so here we had y, if I write out y is equal to f of ux, then when we differentiate this, we differentiate y with respect to u, then we differentiate u with respect to x. So here, the derivative was d on dx, dy on dx is equal to dy on du. So we differentiate the outside function and we multiply that by the derivative. Oh, dy on du, why did I write x? And then we multiply that by the derivative of the inside function. So here, du on dx. The third one was the product rule, which was if we have y is equal to a product of two functions, u and v, the derivative dy on dx, and I'm going to write the shorthand here, was u dash v minus u v dash. And the final one was the quotient rule. So the quotient rule was when we had a function, two functions dividing each other. So u over v, and so the derivative here is equal to, and this one was a long one that I kind of forgot last video, but that's okay, u v dash minus u dash v over v squared. And so we went through these four differentiation rules to help us find the derivative of different functions. And we also did a few questions where we found the gradient of the tangent at any given point. And so that's what we're going to actually focus on in this video. In this video, we're going to look at finding the equation of that tangent. What's the equation of that line at any given point, at a point on our function, and also talking about another thing called our normal. Now, just to help us visualize what this is talking about, if you remember, what we were looking at so far is we were differentiating a whole bunch of different functions, and we substituted the x values in to get the gradient of the tangent. So the tangent is our line, and I'm going to grab this out just so it kind of looks a little bit more accurate, is the line that touches the point, that particular point on my function. So here, if you notice on my function f of x, the black line, we've got a function and we've designated a specific point, x1, y1. The tangent is the line which touches the function at that one point and goes away from it and doesn't touch it ever again. So it's a tangent at that particular point. This is my tangent. And so what we're going to look at is finding the equation of this tangent. Now the other line that we need to know is our normal. Now with our normal, the normal is the line which is perpendicular to this tangent. So here, at this particular point, it is the line which is perpendicular. So here it would be 62 degrees, I believe. At this one point, it's the line that is perpendicular to it. So it meets it at a 90-degree angle. So this line here, this blue line, if I can continue it further, this blue line is my normal. And the thing that we need to know about these two is that they meet at 90 degrees. So in this video, we're going to go through the process of actually finding the equation of normals and tangents and normals. So here we go, finding the equation of tangent. So here I've broken it down into 3 steps. Now, the first step that we want to do when you're finding the equation of a tangent, so we're going to go through finding the equation of a tangent first. Finding the equation of a tangent, first step that you want to do is you want to differentiate, because we want to find our gradient function. We want to find our gradient function. Our derivative, once again, like I've said over the last 2 videos, is the gradient function. It tells me how steep the function is at any given point, and we can sub in different values of x into this function. So f dash of x. So we can sub in different values of x. Then what we want to do is we want to substitute the x value of that point. So in the last video we went through a few questions that did this. We want to substitute the x value of the point that we want to find the tangent of. And so this is the gradient of our tangent. Once we've done that, we want to put it into the equation of a line. Now here I've actually gotten it into two different forms. So here our regular equation of a line is y is equal to mx plus b. Now this one is actually a lot easier to remember, and so I'm going to recommend using this one over what we did in class earlier this year, which was the point gradient formula. This one is sometimes a little bit tricky to remember, so I recommend putting it into this equation. I'm going to show you how. So we need, for this equation, we need our gradient, which is that m part here, and we also then need to substitute the point from the question. So we need our gradient, which we found from the previous part over here. We need the gradient, and we also need the point, which is from our question. So let's have a go at that in this next example. Example: if f of x is equal to x cubed minus 3x, find the equation of the tangent at p 2. Okay, so here we have our function f of x is equal to x cubed minus 3x, and we want to find the equation of the tangent at the point 2. Okay, so like I have in the steps, the first step we want to do is we want to differentiate. We're going to find the derivative. So here I'm going to write f dash of x is equal to, I'm differentiating, I'm bringing the power down for this one and subtracting 1 from each of the powers. So 3x squared minus 3. So I differentiated. This is my gradient function. F dash of x is my gradient function. Second step is then I want to substitute the x value of that point. So if you have a look, my point is 2. So I'm just want to substitute x is equal to 2. So I'm going to sub x is equal to into f dash of x. So I'm going to just write f dash of 2 is equal to 3 times 2 squared minus 3, which is equal to 3 times 4 minus 3, which is 12 minus 3, which gives me 9. Now this 9 is just the gradient of my tangent. So I'm just going to call it m tangent. So m subscript tangent. So this just tells me this is the gradient of tangent. Okay, so that's the second step. First step, differentiate. Second step, substitute the x value of the point. And the third step is then to put it into the equation of a line. Now, if you remember from linear functions, the general equation of a line is y is equal to mx plus b. What I'm going to do, I'm going to substitute this tangent, m tangent, into m, the m value, in my gradient point gradient form, my gradient intercept form. So this just becomes y is equal to 9x plus b. Now notice we have this other term b that we want to find out. So what I need to do to figure that out is then I need to substitute my point from my question. Now my point is p 2. So what I want to do is I want to substitute x is equal to 2 and also y is equal to 2 from my point. So I'm going to substitute those 2 points into my equation. So that's what I'm going to do. I'm going to have 2 is equal to 9 times 2 plus b. So there we go. So this becomes 2 is equal to 18 plus b, and therefore b is equal to minus 16. So putting this all together, then the final step. So therefore my gradient of my tangent is just y is equal to 9x minus 16 from those steps. So here I found my b value down here and I just put it into the equation of my line. So there we go. That's how we find the equation of a tangent. So 3 steps: differentiate the function so we can get the gradient function. Second step, we then substitute the x value of our point. That will give me the gradient of the tangent. Third step is then to put those values, the value of my gradient and also my point, into my equation so that I can find the value of b and then just write the equation together, putting those all those parts together. So that's how we find the equation of a tangent. Now what we're going to do now is we're going to actually find the equation of a normal. Now I'm going to use the same example in a moment, but with the equation of a normal, all the steps are very similar to finding the equation of a tangent. but there's only one difference here. So first, you want to differentiate the function like we did in the first part. So here, once again, we want to find our gradient function. Then the second step is we want to substitute the x value of the point that we get given. So we want to do that exact same step that we did before. We want to substitute the x value of that particular point so we can find the gradient of the tangent. But the additional step that we need to do, this is where 2a comes in. 2a. We want to find the gradient of the normal by using the following equation. So if you remember in class, when we multiply two gradients together, if they're equals to -1, that means the two gradients are perpendicular, which means that they meet at 90 degrees. So here, to find the gradient of our normal, we use this formula, m normal times the gradient of the normal, so m normal, so this is my gradient of my normal, times m tangent, which was, as I said before, the gradient of my tangent, is equal to -1. So we just need to rearrange that for the gradient of my normal. And like we did in the previous example, we're just going to substitute this into the equation of my line. I'm going to use y is equal to mx plus b. So let's have a go at this for the same example. So if f of x is equal to x cubed minus 3x, find the equation of the normal at p is equal to 2, 2. Okay, once again, I'm going to do the exact same thing. We've got my function here. First step is I'm going to differentiate it. So step 1, differentiate f dash of x, and we already found this. This was 3x squared minus 3. Second step is then I need to sub the x value of my point. So here my point was 2, 2, and once again I just need to sub x is equal to 2, x is equal to 2 into my function f dash of x. So here f dash of 2 is just going to be 3 times 2 squared minus 3, and that gave me 9 from the previous question. The thing that is different is then I need to use my equation m normal, and I'm going to shorthand it. Sometimes you see this notation of this line thing. This just means perpendicular. Times, I'm going to just draw it like this. M tangent, I'm going to shorthand it to m tan is equal to -1. And so I just need to substitute my gradient of my tangent, which is this guy over here, 9, into my formula. So m normal times 9 is equal to -1. And so the gradient of my normal is -1 over 9. So here, this is that additional step that we need to add if finding a normal. So this is my additional step for finding normal. And the particular line that I'm keeping an eye on is this guy here. I just need to use the fact that when I multiply the gradient of my normal and my tangent, it will always give me -1. Okay, so I found the gradient of my normal. So all I need to do for part 3 is put it into my equation. So y is equal to mx plus b. I'm going to sub in for m -1 over 9. So y is equal to -1 over 9x plus b. From there, I need to substitute my point. My point hasn't changed. It's 2, 2. And so I sub in x is equal to 2, y is equal to 2. And so here, I'm going to get 2 is equal to -1 over 9 times 2 plus b. 2 is equal to -2 over 9 plus b. So therefore, b is equal to, and I've done this in advance, so this is just 20 over 9. So therefore, the the equation of the normal is equal to y is equal to -1 over 9x plus 20 over 9. And so there we go. That's how we find the equation of my normal. Okay, let's do a question where we have to find both of them together. Find the equation of the tangent and normal at 127 of this function here, y is equal to x squared plus 2 to the power 3. Okay, so let's find the equation of tangent first. Now notice for both of them, the first step and the second step is kind of very similar. So I'm going to do the first step together. So here, we're going to differentiate. I'm going to find dy on dx is equal to. Now notice here, what type of function do we have? We have a function within a function. So with that, what we need to do is we need to differentiate the outside and multiply it by the derivative of the inside. So let's do that. So I'm going to differentiate the outside. I'm going to bring that 3 down. So I've got 3x squared plus 2 to the power 2. I've subtracted 1 from the power, times the derivative of the inside, which is just 2x. So this gives me 6x x squared plus 2 to the power 2. Okay, so that's me differentiating. Now that we've done that, to find the gradient of my tangent, I'm just going to sub x is equal to, well, what's my x value? My point is 127, so I'm going to substitute the x value of 1 into my derivative dy on dx. Okay, so I'm going to get m of my tangent is equal to 6 times 1 times 1 squared plus 2 squared. So it's 6 times 3 squared, which is 6 times 9, which is 54. Okay, so I'm going to first do my tangent here. So tangent. Now that I've got the equation, the gradient of my tangent, I'm just going to sub it into my equation of my line. So y is equal to 54x plus b. Then from there, if you remember, what we need to do is we need to sub in our point. So I'm going to sub my point. My point was 127 into line. So I'm going to get, what's my x value from this point is 1. X is equal to 1. And my y value is 27. So I'm going to substitute that in. So I'm going to get 27 is equal to 54 times 1 plus b. And so therefore b is equal to negative 27 when you rearrange this equation. So therefore my tangent is equal to y is equal to 54x minus 27. Okay, that's the first part, my tangent. Now I also want to find my normal. Now the additional step that we need to have with my normal was I want to find the gradient of my normal, which I use the fact that when I times it with the gradient of my tangent is equal to negative 1. So my gradient of my tangent on the top was 54. So I'm going to go m normal times 54 is equal to minus 1. So m normal is equal to negative 1 over 54. And then I sub that into my equation. So therefore, the equation of my line, y is equal to negative 1 over 54x plus b. And like we did in this example over here, we want to substitute my point into my line. So I'm going to sub P127 into line. So I get 27 is equal to negative 1 over 54 plus b. So therefore, b is equal to, I'm going to put this in my calculator. 27 plus 1 over 54. So here we've got 27. Let me try that again. 27 plus 1 over 54. So I get 1459 over 54. So therefore, my normal is y is equal to negative 1 over 54x plus 1459 over 54. So there we go. I found the equation of my normal and my tangent. So quick summary of this whole video. When we're trying to find the equation of a tangent or a normal, first step is always the same. First two steps are always the same. Differentiate to find the gradient function. Then we substitute the x value of the point that we're looking at where for the tangent or the normal, so that we get the gradient of the tangent. Then if you're using the tangent, all you need to do is just sub that into the equation of a line along with your point to get the equation of the line, like we did on the left hand side over there. If you are trying to find the gradient of like we did on the left hand side over here, so this part here. If you're trying to find the equation of a normal, however, we have to add that additional step of finding the gradient of the normal. And so for that, we need to use this line, the gradient of the normal is equal to the gradient of the gradient of the normal times the gradient of the tangent will give me minus 1, and then do the exact same step that we did before. So that's how we find the equation of a tangent and a normal. Hopefully this was helpful and you can now have a go at the questions in the revision booklet.